Have you paid attention to the weather forecast and the isobaric maps? Weather maps include information about the velocity and direction of the air in the atmosphere. These interesting maps are isobaric maps, maps of pressure. They indicate the pressure at certain height. It is pressure differences that push the air in one direction or another. This, combined with Earth's rotation, gives interesting and sometimes complex weather patterns. If the flow of fluid is regular, we call it laminar flow. We can describe it as the particles flow in parallel trajectories. If the flow of the fluid is irregular, it presents whirls. We call it turbulent flow. The trajectories of the particles change direction over time. The laminar or turbulent behavior of a fluid flow on a pipe depends on the velocity. For low velocities, we find a laminar regime, while for high velocities, the flow enters in a turbulent regime. We will center our study in the laminar regime, and we will consider cylindrical pipes for simplicity. Let me now define the flow rate as the volume of liquid that passes a section of the pipe per unit time. Q equal to dV over dt. The volume can be written as cross-sectional area of the pipe times the distance traveled by the fluid. So this derivative is the area times dx over dt. Flow rate is then area times velocity. So the flow rate will be higher the larger the cross-section and the higher the velocity. Both variables here are relevant. Something interesting happens when the pipe changes its cross-section. If we are dealing with a non-compressible, so that the volume is not going to change, liquid, and pipes that have no leakage, then the same amount of fluid has to pass each point per unit time. If the pipe narrows, this implies that the fluid needs to move faster and vice versa. Q1 is equal to Q2 and A1V1 is equal to A2V2. This is called the equation of continuity. This equation assumes that the fluid is incompressible. If you like canoeing in the summer, you might have experienced this as the river opens or narrows. Also, as you water the plants in the summer with a hose, you might put your thumb to close a little bit the nozzle of the hose so that the water exits faster and reaches farther. Yeah, you are surrounded by science.